This is lesson 3.1, use shadow, drop shadow, and inner shadow. Let's begin with a general discussion of effects in JavaFX. So what exactly are effects? In JavaFX, an effect is a graphical algorithm that modifies a source image. To apply an effect, you set the effect property in the node class. Now you can apply an effect to almost anything in JavaFX, from a shape like a rectangle or circle, or a UI control like a button or text field. You can also apply effects to groups of nodes. And the effect itself is actually a graphical filter that accepts at least one input and modifies it in some way. Now why should you use effects? First of all, effects let you change color properties, shift pixels, and apply blurring, blending, and tones to your scene graphs. Effects can also show lighting, reflection, and perspective. Effects are useful because they can make images appear three-dimensional. And the output of one effect can actually be set to the input of another. This lets you chain effects together and combine their results. Now before we start showing you effects, let's take a quick look at the effects hierarchy in JavaFX. Here, effect is an abstract class. The rest of the diagram is the first group of concrete classes for the JavaFX effects. You see many effects here, like different shadows and blurs, as well as blend, bloom, glow, and tone effects. Now there's actually more effects than just these, so let's show you the rest of them now. Once again, effect is an abstract class. And the rest of this diagram is the second group of concrete classes for the JavaFX effects. You see effects like lighting and reflection, as well as displacement and perspective effects. You also see effects that adjust colors and input images and input colors. Note that in both diagrams, effect is not a subtype of node. This means you must set the effect property in the node class to apply an effect to a node or a group of nodes. And as you will soon see, this is typically done by invoking the setEffect method. Let's show you our first JavaFX effect now. A shadow effect creates a monochrome duplicate of an input with blurry edges. It's used primarily with its default black color, so you can combine it with the original color and create shadow effects. Here are the useful properties of a shadow. Color is the color of the shadow, which is black by default. Width is the horizontal size of the shadow, and height is the shadow's vertical size. For both of these properties, the range of values is 0 to 255 with defaults of 21. Radius is the radius of the shadow. The range of this property is 0 to 127 with a default of 10. Blur type is like a Gaussian blur or other types of blurring filters for the shadow. The default here is a 3-pass box filter. And finally, the input for this effect. This property is used for chaining effects, which we'll discuss in a later lesson. Let's show you a JavaFX program now that uses a shadow effect. This is the My Shadow program, which shows you how to create a shadow effect and configure its properties. Let's compile and run this program and see what it displays. What appears here is a text string, a circle, and a rectangle configured as a square. Note that all shapes are black with a blurred shadow effect. Let's look at the JavaFX code now for this program. First, the program creates a shadow object with the default constructor. The call to setRadius sets the radius of the shadow blur to 5. The text constructor creates a text object at 150/50 with a text string. The setter sets the text font to Verdana Bold with a point size 40, and this setter sets the text string's fill color to dark red. And here's where we call setEffect with the shadow object as an argument. This applies the shadow effect to the text node. Note that the default black color of the shadow prevents the dark red colors of the text string from appearing. Now let's look at the code for the circle and the rectangle, which is similar. This constructor creates a circle at 180/20 with radius 40 and a Dodger blue color. And here's where we apply the shadow effect to the circle. Likewise, the rectangle constructor creates a rectangle at 260/80 with width and height 80. And this setter sets the rectangle's fill color to light green, and here is where we apply the shadow effect to the rectangle. All three shapes are added to the root scene graph here. Once again, notice that the colors of the circle and rectangle do not appear because of the black shadow effect. Let's remove the shadow effect from the text object and see what happens. When I recompile and run the program, you see the dark red text string now appear as a sharp image. Let's remove the shadow effect from the other shapes. Here for the circle, and here for the rectangle. When I recompile and run, you now see that all the shadows have been removed. Of course, if you want shadow effects applied to all the shapes, you could do that in one statement. Instead of calling setEffect separately for each shape, I'll invoke it with the root right here. When I recompile and run the program, you see that the shadows are now applied to all the shapes. This works because the text, circle, and rectangle are part of the same group. Next, I'll modify the properties of the shadow effect. First, I'll set the radius to 10, a larger number. As you will see, this will increase the blur of the shadow effect. Okay, let's put it back. Now it turns out that when you set the radius property of a shadow, it's the same as setting the shadow's width and height properties to 2 times radius plus 1. So let's do that here. When I recompile and run the program, you'll see the same appearance. And finally, I'll invoke setColor right here to change the shadow's color. When I recompile and run this program, you see all the shadow colors are now dark blue. The next effect is DropShadow. DropShadow renders a shadow of the content that makes images look three-dimensional. DropShadows also give the appearance of light coming from one direction and casting a shadow. Here are the useful properties for a DropShadow. Offset X and Offset Y are shadow offsets in the XY direction that let you manipulate the direction of the drop shadow. Negative values for Offset X make the drop shadow appear to the left of the object, and negative values for Offset Y make the drop shadow appear above. Positive values for Offset X and Offset Y place the drop shadow to the right and below, respectively. Now color, width, height, radius, and input properties are all the same as shadow. And property spread defines a sharpness level for the drop shadow. A spread value of 1 makes the shadow sharply delineated. A value of 0 is the default and provides a fuzzy appearance. Okay, let's show you a JavaFX program now that uses the drop shadow effect. This is the My Drop Shadow program, which shows you how to create a drop shadow effect and configure its properties. Let's compile and run this program and see what it displays. What appears here is a dark green text string, Dodger blue circle, and light green rectangle configured as a square. Note that drop shadows appear on all the shapes. On the text string, you see a drop shadow, you see a drop shadow on the circle, and another drop shadow on the rectangle. In all cases, the drop shadow is below the shape and to the right. Okay, let's show you the code now for this program. First, the program creates a drop shadow object with the default constructor. The calls to setOffsetX 4 and setOffsetY 6 make the drop shadow appear 4 pixels to the right and 6 pixels below. The color of the drop shadow is set here. Next, the program creates the text, circle, and rectangle objects and configures them all with setters. Note that the shapes are set up the same as the previous program, except for the text string, which is now dark green. And after adding these shapes to the root group scene graph here, the drop shadow effect is applied to the root group. To learn how to manipulate drop shadow effects, let's modify our program and show you the results. First, I'll make this set offset x -4. When I recompile and run the program, you'll see that the drop shadows have moved. They now appear to the left and below. Next, I'll make the set offset y -6. When I recompile and run the program, you'll see that the drop shadows now appear to the left and above. Let's change the set offset x now back to 4. When I recompile and run this program, you see that the drop shadows appear to the right and above. And finally, if I make offset x 8 and offset y 12, when I recompile and run the program, you'll see the drop shadows move more to the right and down. Okay, let's give you some general tips about drop shadows now. 1. Don't make drop shadows too wide. It makes them look heavy. 2. Pay attention to the color of your drop shadow. Generally, drop shadows should be a few shades lighter than the background color. And 3. If you have multiple objects with drop shadows, make all the drop shadows the same. This makes your scene graphs look more pleasing to the eye. The last shadow effect is InnerShadow. InnerShadow renders a shadow inside the edges of your content. This gives you a three-dimensional look, specifically a sunken appearance. Now the properties for an InnerShadow are the same as the ones for DropShadow, except for two differences. First, offset x and offset y have different behaviors for InnerShadow. Negative values for offset x make the InnerShadow appear to the right of the object, and negative values for offset y make the InnerShadow appear below. Positive values for offset x and offset y place the InnerShadow to the left and above, respectively. The other difference is that InnerShadow has a choke property. Property choke is the portion of the radius where the source distribution will be 100%. The default value of 0 results in a distribution of the shadow determined entirely by the blur algorithm. And a value of 1 results in a solid growth inward of the shadow from the edges. Let's show you a JavaFX program now that uses an InnerShadow effect. This is the My InnerShadow program, which shows you how to create an InnerShadow effect and configure its properties. Let's compile and run this program and see what it displays. What appears here is a cyan text string, Dodger blue circle, and light green rectangle configured as a square. Note that inner shadows appear on all the shapes. You see an inner shadow on the text string, an inner shadow on the circle, and an inner shadow on the rectangle. And in all cases, the inner shadow is above the shape and to the left. Let's show you the JavaFX code for this program now. First, the program creates an inner shadow object with the default constructor. The calls to set offset x 4 and set offset y 6 make the inner shadow appear 4 pixels to the left and 6 pixels above. The color of the inner shadow is set here. Next, the program creates the text, circle, and rectangle objects and configures them with setters. And after adding these shapes to the root group scene graph here, the inner shadow effect is applied to the group. Let's manipulate the offsets for the inner shadow in this program and show you the results. First, I'll make offset x -4. When I recompile and run the program, you'll see that the inner shadows have moved. They now appear to the right and above. Next, I'll make offset y -6. When I recompile and run, you'll see that the inner shadows appear to the right and below. Let's set the offset x back to 4 now. When I recompile and run, you see the inner shadows appear now to the left and below. And finally, I'll make offset x 8 and offset y 12. When I recompile and run this program, you'll see the inner shadows have become larger for all three shapes. And notice how all the shapes appear more sunken now.